Good day everyone! In this video, we will discuss about binomial theorem. In the previous video, we have discussed about the Pascal's triangle and how to use it in determining the expanded form of a binomial expansion. For small values of n, the Pascal's triangle conveniently produces the coefficients of the expansion of a plus b quantity raised to n. However, as n increases, the use of the triangle becomes impractically tedious. With this, if the value of n is much higher, instead of determining the coefficients of the terms of the expanded form, we can use the binomial theorem instead. The binomial theorem states that if n is a positive integer, then a plus b raised to n is equal to n taken 0 times a raised to n plus n taken 1 times a raised to n minus 1 times b plus n taken 2 times a raised to n minus 2 times b raised to n minus 2 plus and so on and so forth plus n taken n minus 1 times a times b raised to n minus 1 plus n taken n times b raised to n. This long expression can be expressed by a summation notation as the summation of n taken k as k goes from 0 up to n times a raised to n minus k times b raised to k, where n taken k is equal to n factorial over k factorial times n minus k factorial. Let us try to solve some examples using the binomial theorem. For the first one, expand the expression 2x plus 1 quantity cube using the binomial theorem. With this, notice that the value of n is equal to 3. Therefore, 2x plus 1 raised to 3 will be equal to 3 taken 0 times a raised to 3 plus 3 taken 1 times a squared b plus 3 taken 2 times a b squared plus 3 taken 3 times b cubed. Next, going back to our given, notice that a is equal to 2x and b is equal to 1. Substituting 2x to a and 1 to b, then the expression will become 3 taken 0 times 2x cubed plus 3 taken 1 times 2x squared times 1 plus 3 taken 2 times 2x times 1 squared plus 3 taken 3 times 1 cube. Next step is simplify this part of our equation. Hence, we're gonna have 3 taken 0 times 2x cubed is equal to 8x cubed plus 3 taken 1 times 2x squared is equal to 4x squared times 1 is still 4x squared plus 3 taken 2 times 2x times 1 squared is equal to 2x. And finally, 3 taken 3 times 1 cube is simply equal to 1. The next step would be simplifying 3 taken 0, 3 taken 1, 3 taken 2, and 3 taken 3. To do that, we will be using the formula n taken k is equal to n factorial all over k factorial times n minus k factorial. So for the first one, we will have 3 factorial all over 0 factorial times 3 minus 0 quantity factorial times 8x cubed plus 3 taken 1 will be equal to 3 factorial all over 1 factorial times 3 minus 1 quantity factorial, then times 4x squared plus 3 taken 2 would be equal to 3 factorial all over 2 factorial times 3 minus 2 quantity factorial, then times 2x plus 3 taken 3 will be equal to 3 factorial all over 3 factorial times 3 minus 3 quantity factorial times 1. From here, we need to evaluate these factorial notations. Recall that n factorial is actually equal to n times n minus 1 times n minus 2 and so on and so forth times 3 times 2 times 1. Therefore, it is a repeating multiplication from the given number n up to 3, 2, and 1. So therefore, 3 factorial is actually equal to 3 times 2 times 1. All over 0 factorial is equal to 1 times 3 minus 0 is equal to 3 factorial. So meaning this is equal to 3 factorial, which is still 3 times 2 times 1. Then copy 8x cubed plus 3 factorial is again 3 times 2 times 1 all over 1 factorial is equal to 1 times 3 minus 1 is equal to 2 factorial. So that would be 2 times 1. Then copy 4x squared plus 3 factorial. Again, that is 3 times 2 times 1 all over 2 factorial is 2 times 1. And then times 3 minus 2 is 1. Factorial is still 1. Then copy 2x plus 3 factorial is 3 times 2 times 1 all over 3 factorial is 3 times 2 times 1 times 3 minus 3 is 0 factorial is 1 times 1. Let us simplify these expressions here, but before multiplying and dividing them, you may cancel common factors. So for example, in here, you may cancel 3, 2, and 1, giving you with 1 over 1 times 8x cubed, then that would only be equal to 8x cubed. Next, before you multiply again, cancel common factors. So you only have here 3 divided by 1, which is equal to 3, times 4x squared is positive 12x squared. Next term, cancel the common factors, giving you with 3 divided by 1 is still 3, times 2x is 6x. And finally, for the last one, cancel the common factors. So you only now have here 1 times 1 will be equal to 1. Therefore, this is the expanded form of the given 2x plus 1 quantity cubed. Let us have another one. Expand the expression x minus 3 quantity raised to 4 using the binomial theorem. In here, n is equal to 4. So what we will do is to list down first the terms. So you will be starting with 4 taken 0 times a raised to 4 plus 4 taken 1 times a cubed b plus 4 taken 2 times a squared b squared plus 4 taken 3 times ab cubed plus 4 taken 4 times b raised to 4. Next, looking at our given x minus 3, we can see here that our a is equal to x and our b is equal to negative 3. Therefore, we will have 4 taken 0 times x raised to 4 plus 4 taken 1 times x raised to 3 times negative 3 plus 4 taken 2 times x squared times negative 3 squared plus 4 taken 3 times x times negative 3 cubed, and last is 4 taken 4 times negative 3 raised to 4. Next step, simplify these expressions. Then we will have 4 taken 0 times x raised to 4 plus 4 taken 1 times x cubed times negative 3 is equal to negative 3x cubed plus 4 taken 2 times x squared times negative 3 squared is 9. Then we will have 9x squared plus 4 taken 3 times x times negative 3 cubed is negative 27x plus 4 taken 4 times negative 3 raised to 4 is equal to 81. Next step is to simplify the expressions 4 taken 0, 4 taken 1, 4 taken 2, 4 taken 3, and 4 taken 4. Recall that we will be using the formula for n taken k to be n factorial all over k factorial times n minus k quantity factorial. Therefore, we will have the following terms as 4 factorial all over 0 factorial times 4 minus 0 quantity factorial times x raised to 4 plus, for the next term, we have 4 factorial all over 1 factorial times 4 minus 1 quantity factorial times negative 3x cubed plus, for this one, we're gonna have 4 factorial all over 2 factorial times 4 minus 2 quantity factorial times 9x squared plus 4 factorial all over 3 factorial times 4 minus 3 quantity factorial times negative 27x plus 4 factorial all over 4 factorial times 4 minus 4 factorial times 81. Next is to express 4 factorial and the rest of the factorial notations to be 4 factorial is equal to 4 times 3 times 2 times 1 all over 0 factorial is equal to 1 times 4 minus 0 is 4 factorial. So that would be 4 times 3 times 2 times 1 times x raised to 4 plus 4 factorial here, again, is equal to 4 times 3 times 2 times 1 all over 1 times 4 minus 1 quantity factorial is equal to 3 factorial, which will be equal to 3 times 2 times 1 times negative 3x cubed plus 4 factorial here, again, is equal to 4 times 3 times 2 times 1 all over 2 factorial is equal to 2 times 1 times 4 minus 2 is equal to 2 factorial here. So 2 times 1 times 9x squared plus 4 times 3 times 2 times 1 all over 3 factorial is 3 times 2 times 1. 4 minus 3 is 1 factorial. So that is 1 times negative 27x plus 4 times 3 times 2 times 1 all over 4 factorial is 4 times 3 times 2 times 1 times 4 minus 4 is 0 factorial is equal to 1 and then times 81. Next, simplify, but before simplifying, we may cancel common factors. So here we can cancel 4, 3, 2, 1, 4, 3, 2, 1, leaving us with 1 divided by 1 is 1 times x raised to 4 is equal to x raised to 4. Then next is cancel 3, 2, 1, cancel 3, 2, 1, giving us with 4 divided by 1 is 4 times negative 3x cubed. So we will have negative 12x cubed. So negative 12x cubed. Then next, we can cancel 2, 1, 2, 1. Then 4 and 2. And 4 will become 2. So what we have here is 2 times 3, which is 6, divided by 1 is 6. Times 9x squared is 54 or positive 54x squared. And then for the next one, cancel 3, 2, 1, 3, 2, 1. So 4 divided by 1 is 4 times negative 27x is negative 108x. And finally, cancel 4, 3, 2, 1, 4, 3, 2, 1, leaving us with 1 divided by 1 is 1 times 81 is positive 81. Therefore, this is the expanded form of the given binomial expansion. The binomial theorem is also useful when determining a specific term in a binomial expansion. For example, determine the fifth term of the expansion x plus 2y quantity raised to 6. Since we have n equals 6, then note that the expanded form has 7 terms. So we're gonna have a total of 7 terms, wherein the last term will definitely be equal to b raised to 6. If we will do working backwards, if the last term is b raised to 6, then it only follows that the term before it is a b raised to 5. And the term before it is a squared b raised to 4. So remember that this is your 7th term, this is your 6th term, and this is your 5th term. Therefore, we are looking for this term with variables a squared b raised to 4. Since we are looking for the 5th term as well, it only follows that since we have 2 here, then the term is actually equal to 6 taken 2 times a squared b raised to 4. Because remember that the exponent here and the number here are always equal. So therefore, going back on our given x plus 2y quantity raised to 6, we can see that a is equal to x and b is equal to 2y. Therefore, substituting this on this term, then we gonna have 6 taken 2 times x squared times 2y raised to 4. Moreover, 6 taken 2 is actually equal to 6 factorial all over 2 factorial times 6 minus 2 quantity factorial times x squared times 2y raised to 4. Now, 2y quantity raised to 4 is equal to 16y raised to 4 times x squared. So, that would be 16x squared y raised to 4. Next thing to do is to simplify this factorial notation here. So, we gonna have 6 times 5 times 4 times 3 times 2 times 1 all over 2 times 1 times 6 minus 2 is 4. Factorial is 4 factorial. So, we will have 4 times 3 times 2 times 1 then times 16x squared y raised to 4. Next, simplify this by canceling common factors. So, cancel 4, 3, 2, 1. And you may also cancel 6 and 2 here. So, 6 divided by 2 will give you 3. So, 3 times 5 will give us 15 times 16 x squared y raised to 4. Then, that would be equal to 240 x raised to 2 y raised to 4. Therefore, this is the fifth term of the expansion. Notice that the binomial theorem is very useful in determining specific terms without actually solving for the entire expanded form. I hope that you have understood the lesson. For our next video, we will be discussing the first topic for quarter 2. Thank you for listening and see you on our next discussion.